Hello everyone, welcome to this video. In this video, we'll be solving question 19 from miscellaneous exercises on chapter 9, class 11th. So the 19th question here says that the ratio of the arithmetic mean and the geometric mean, right, of two positive numbers a and b is m/n. This is given to us. Then we need to show that the ratio of a is to b is this much. So you know what is the arithmetic mean between two positive numbers a and b? That is given by a plus b divided by 2. So you can mark it by equation 1. Similarly, what is the geometric mean of two numbers a and b? It is given by square root of ab. So you can mark it by equation 2. Correct? So in this case, you have both the arithmetic mean and the geometric mean. So what is their ratio? It is given that their ratio is m/n, right? So you can substitute the value of arithmetic mean and that of geometric mean here into this ratio. And by ratio, what do you mean? This term divided by this term is equal to this term divided by this term, right? So here we have done exactly the same thing. So you can simplify this double expression, double division, right? So that you would have a plus b divided by 2 square root of ab. This is equals to m/n, right? Now what you need to do? You need to find what is the value of a/b. So from this expression, you have to simplify and reach up to the expression of a/b. So how we can do that? Can you see a pattern here? What you have a plus b and you have 2 square root ab. So what you can do, you can apply the formula of componendo and dividendo. So what you can do, you can add up the numerator and denominator and put it in the numerator like this. And then you can subtract both the numerator and denominator and put it here in the place of denominator. And similarly, we'll do on the right hand side. So once you have completed this, you can write a as the square root of a square, b as the square root of b square. Why we are doing this? Because we wanted to make it into the square of something, right? Because it is in the same form. We have plus, this is plus 2 square root of a square root of b. So what if we write a as square root of a square and b as square root of b square? So this would be exactly the same thing. However, now we can write it in the form of the perfect square of square root a plus square root b, because once you open it, you would have this formula only for it. Similarly, in the denominator, we have a negative sign. So that means we would now have a formula for a square root a minus square root b whole square. So this formula over here, correct? So you have the square of this thing is equals to this. So in order to remove the square, because we wanted what is the value of a/b, what we can do, we can take square root on both sides, so that we have this expression is equals to the square root of m plus n divided by the square root of m minus n. Now here also you see we could cancel out some terms if we apply componendo and dividendo again. So basically what we are doing, we are adding the numerator with the denominator first of all, and then we are subtracting the numerator and the denominator, so that we would have some terms cancelling with each other. So you see the square root of b cancels here, square root of a and square root of a cancels here. Here nothing happens, you just have to apply componendo and dividendo. So you see you have 2 times of square root a left with you and 2 times of square root b left with you, correct? So that this term would be the same. So this 2 and 2 also gets cancelled. So we have this term. Now what we want a/b. But however, we have square root a, square root b. So what we can do, we can square both sides, so that we would have this square and this square. So this square is nothing but a/b, correct? a/b. And you have to do the square of this thing, numerator separately and the denominator separately. So how can you do? You can do the square of this plus the square of this plus 2 times the square plus 2 times this multiplied with this term. So you have the first term, second term, and plus 2 times the first term and the second term, square of first term and second term. Similarly, in the denominator here, the square of first term plus the square of second term minus 2 times the first term and the second term, right? So here you see n and n gets cancelled in both the numerator as well as in the denominator. So you have left with 2m, right? And here it is 2, this term as such, Here also 2m minus 2 this term as such. So you can again take 2 common and then you could cancel these out, so that you are left with m plus. Now what is the identity for m plus n, m minus n? It is equal to m square minus n square. So using this identity and writing down it here, we have what was required in our question. So the ratio of a is to b here comes out to be m plus square root of m square minus n square to m minus square root of m square minus n square, and this is what we wanted to prove here in this particular question. So I hope you understood this question well. That is it for this video. Thank you for watching.